The periodic table helps us organize and understand some of the trends for many of the elements. You can see that it has three general areas. It has, from this area all the way to here, it has metals. And then to the right of this staircase, we have the nonmetals. Also included in that is hydrogen. And then between our metals and nonmetals, we have the metalloids, which have properties somewhat like metals and nonmetals. Metals generally are lustrous and malleable, and they conduct electricity well. And nonmetals, they do not have those properties. Metals are generally solids at room temperature, although mercury is a liquid, and nonmetals can range from solid to liquid to gas. Now, we also have more specific groups. We have, in our first group, and a group, it goes up and down the periodic table. So in group 1, we have the alkali metals. These all are similar in that they all bind with one hydrogen, and they all react fairly violently with water. We then have, in group 2, the alkaline earth metals. They all bind with two hydrogens, and they also react somewhat with water. Other important groups, we have the halogens in group 7A here. They will bind with one hydrogen, and then we have the noble gases, which will not bind with anything, really, besides krypton and xenon occasionally reacting with a few things. We see that these groups are similar in properties. As we look through all of these alkali metals, they are all similar in being metals that react with one hydrogen and react violently with water. Similar properties in each group. In fact, this similarity in properties is how the periodic table was organized. It was at first organized by increasing mass. So you could see atomic mass of 1, and then 4, 7, 9, etc. Now this trend in mass actually was very convenient in lining up the halogens together, etc. So that worked pretty well. But there was one problem in the periodic table, and that is tellurium actually had a place here, and then iodine had a place here when organizing by atomic mass. You see that tellurium has a mass of 127.6, greater than iodine 126.90. But of course, iodine actually behaves very similar to bromine, chlorine, and fluorine, not to selenium, sulfur, and oxygen. So in fact, these guys had to be switched. Iodine and tellurium were switched so that iodine now is in the same group as the halogens, because later it was discovered that it had 53 protons, tellurium had 52. It was discovered that we shouldn't organize the periodic table by atomic mass, but instead by atomic number, the number of protons. So now we've got iodine in the right place and tellurium in the right place. Yes, we organize by protons. We leave some extra spaces so that halogens line up with each other, etc. And it allows us to then predict the properties of certain elements. For example, what element do you think would be very similar to platinum in terms of how many things it might bind with and its ability to catalyze? Well, it's palladium. It's in the same group. What element would be very similar to barium? How about strontium and calcium and magnesium and beryllium? They'll get +2 charges. So, a very convenient thing here. Just a couple other notes. We have, within the D block elements, we have the transition metals. And then within the F block, we have the inner transition metals. We don't actually put them here. They belong here, but we've shifted them down to leave enough room for everything else. Otherwise, the periodic table would be far too large. We've shifted these inner transition metals lower than they should actually be. Okay, thanks for watching, guys.